Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. It's really not that hard to learn the hard skill that is the mathematics of finance. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I always like to start class with a quote. Here we go. The quote of this lesson is, "If you work it, learning, like a job, you can't fail." Thank you, Gary Whittington. Whit, as he's known, is my mentor. He's a mentor to many, in fact. He's the person who got me into running and writing, someone I'm proud to call a friend. And that's where I start. I'm not sure where I would end describing the impact that Whit has had on my life. In fact, as I was running here to record this video, I'm actually not that nervous. I was thinking about how Whit loves to drop all kinds of running wisdom. Everything from you can't outrun your training or the weather to 5 miles is the new 3. I'm sure you have one or more people in your life that has helped you figure stuff out. Let me share another story because that's how I teach. Storytelling is an effective form of communication. In fact, it's the most effective form that I've found. Information is not effectively processed through facts alone. The year was 1995. That's when I received a really important lesson, which came in the form of a Post-it note from another person who was as funny as he is smart, my favorite combination. It happened in Fort Dodge, Iowa. It's one word if you're from there, Fort Dodge. The Post-it note was an answer to the question, what are you going to do with your life? When I told Mike Trotter that I could maybe see myself as a finance professional someday, that's when he quickly reached for a nearby Post-it note and a pen, and with a look on his face that told me something big was coming, a big question needs a big answer, he wrote this equation, the building block future value equation. You're looking at a reproduction in Mike Trotter's own handwriting, and I wish I had that Post-it note from 1995. I didn't realize it at the time that his quote-unquote lesson was going to put me on a course that would lead me to you today. A professional engineer, Mike Trotter understood well the importance of math in his line of work. Beyond that, he also understood the fact that the finance industry is essentially built on the power of compounding. Let's examine the building block future value equation. It's not a formula, there's an equal sign. If compound investment yield, feel free to substitute the word interest for investment yield if you like, is an investor's best friend, then time is a close second. But we can't forget about money. It's expected that money, when invested over time, will increase in value, which ultimately stems from the true investment yield. Let me say that again. And will you do me a solid by really focusing on the variables in this building block time value of money equation while I repeat that statement? Here we go. It's expected that money, when invested over time, will increase in value, which ultimately stems from the true investment yield. The true investment yield, or I, shows up in the building block future value equation. Of course it does. It shows up in every building block time value of money equation. If you're still in the habit of referring to this as compound interest, I'm not going to be mad at you, but I am going to try my hardest to get you to change your mindset around this variable because not all investments pay interest. The better term, because it's a catch-all term, is true investment yield. Now, some textbooks we'll denote this as lowercase r, but don't get me started. I'm actually going to teach you how to apply the mathematics of finance such that you can do it in your sleep, as they say, after that traditional finance textbook puts you to sleep as an unintended bedtime story. So let's go through an example, and I'm going to draw you a mathematical expression. It's what I like to refer to as the flux capacitor of finance. 1 plus I, and I is the true investment yield, raised to the nth power, uppercase N. So the true investment yield, when considered with time, 1 plus I raised to the nth power, again, what I like to call the flux capacitor of finance, is the value activator. Since time alone doesn't bring about more value for money. This mathematical expression, as you'll see, shows up in every one of the building block time value of money equations. So let's go back to the building block future value equation. Here's an example. If you had $1 in the present and you put it under your mattress for 12 months, I don't know why you'd want to do that, but that's how this example goes. In your mind's eye, can you see where the values would go in this equation? I'm going to write it out. So you've got $1, and for whatever reason, you're considering putting that dollar under your mattress. We don't yet know the true investment yield, hint, hint, hint. So what would that look like here? We're going to draw this out. I'm going to draw this on the Post-it note that Mike Trotter gave me. So how do we fill this in? We've got future value equals, we've got our $1. I like to put a multiplication sign in here, times 1 plus I, that's the true investment yield. We don't know what that is yet. And N takes the form of 12 because we're telling time in terms of months. So first I want to draw your attention to the exponent, that variable with the uppercase N. Don't confuse this with its close relative lowercase n. You can think of lowercase n as the time span in between period markers on the timeline, and uppercase N as the total investment period that is subject to the same true investment yield and the same time span in between period markers on the timeline. That's kind of a mouthful. We'll come back to that later in this introductory unit, but for now, that should be enough to hold you over. So why don't you store money under mattresses? Well, the answer is pretty simple. Because there are markets for capital, i.e. money. If there's one thing that makes the time value of money a thing, it's this idea of being indifferent between values of money in different points in time. Because there are markets for capital. There are people who have money to invest, and then there are those who need or want money and are willing to pay quote unquote financial rent for the use of other people's money over a certain period of time. TVM rule number 1, or time value of money rule number 1, is never add or subtract or compare money in different points in time. Why? Because there are markets for capital. Again, those who have money to invest and those who need or want money and are willing to pay others in the form of an expected investment yield, which could be, but doesn't have to take the form of interest. So as a result, there's a value, not worth, that makes an investor indifferent between money in different points in time for a given investment yield in a certain investment period. Take 2 with another example. Now the story goes, you've got $1 in the present, and you expect that you could earn a monthly return on investment of 0.2994%. In this example, that's just a fancy way of saying that the true monthly investment yield is 0.2994%. Using just these two inputs, again, just these two inputs, forget about 12 months for a moment, can you see where the values would go in this equation? So let's write this out. What does this look like now? We've got future value equals $1. Again, I like to use the multiplication sign. In parentheses, 1 plus 0.0029994 raised to the nth power. Again, we don't know how we're telling time in this second example. I want to point out a couple things. First, do you see how the true investment yield takes the decimal form? In other words, 0.002994 as opposed to the percentage format that is 0.2994%. It's important to point that out here because you need to use the decimal form or this isn't going to work. The number is going to be wrong. So do you see what's missing? In this example, value in the form of the return on investment, it's never realized because the money was never given time to grow. Okay, take 3. With this example, the story's a little different. Now we know that the market is expected to provide a true monthly investment yield of 0.2994%. That's still in the storyline. So say you had a 12-month investment horizon in mind, but in this example, you don't have any money to invest. You're flat broke. What's that equation look like? Let's write it out. Future value equals present value, because we don't have any money to invest here, times 1.002994. That's 0.2994% for a true monthly investment yield. And we raise this to the power of 12. Why? Because we're telling time in terms of months. And this example contemplates a 12-month investment horizon. And again, we changed the story up a little bit and we said we're flat broke. We don't have $1 to invest. The first thing to point out is in parentheses, we've added the decimal form of 0.2994% to the 1. This is how you would do this in practice and when solving for a time value of money question. We don't want them to be problems. So in this example, maybe you chose to consume the money at the expense of its future value, or maybe you didn't even earn the money in the first place. So I want you to take another look at the building block future value equation. I'd like you to read the variables from right to left. I know we normally read from left to right, but here, do me a favor, read from left to right. Can you translate these variables into time, value, and money? That's what I'm talking about. Uppercase N is where time enters into the equation. Lowercase I, also known as the true investment yield, is where value comes into this equation. And PV, short for present value, is where money comes into this equation. You may never look at the building block future value equation the same way again. So in summary, it takes time, value, and money for the time value of money to work its magic and to get that snowball of compounding rolling. Speaking of snowballs, most people don't have a real excuse for why they can't become a millionaire. And the building block future value equation provides that proof. Here's an example. Do you have any idea? Let's start with a question. Do you have any idea what $10,000 when invested over 60 years and expected to earn a return on investment of 12%, that's a true annual investment yield, might grow to in terms of a future value? Now, before you answer that question, or before I provided the answer, you might be thinking, but that's a long time. That's a lot of money, and maybe even 12%, that doesn't even really seem like it's available in the market. Well, are you done making excuses yet? You'll never know unless you try. And let's not forget that the time value of money, it's not also about helping you to change your life, but to change your family tree. You see, that's what I think about every time I see the money tree. That's the frontispiece in our book, Would Your Boomerang Return? It's also the illustration that shows up on the first slide. It reminds me that it's about changing your family tree. Every time I see it, that's what I'm reminded about. So do you want to know the estimate for the future value? Get ready for this. It's $8,975,969, and don't forget about the cents, 34 cents. So who wants to be a millionaire? I'm going to write this out for you in the event that you want to work on this in your spare time, because we all got a bunch of spare time, don't we? Future value, thank you, Mike Trotter, equals present value multiplied by the flux capacitor of finance, 1 plus I raised to the nth power, and let's fill it in. Future value equals $10,000, we don't need to include the dollar sign here, times 1.12, that's 12%, raised to the power of 60, because here we're telling time in terms of years. And when we work this out, we find the estimate is 8,000,000, I don't want to get this wrong, $975,969, and don't forget them, 34 cents. Now, I realize that this doesn't consider ups and downs in the market. These are assumptions. We need values for these inputs, but I'm just saying, even if I'm half wrong, wouldn't you like to have almost $4.5 million? Exactly. So that's a wrap. If you liked what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. We like 3-act structures here at Box Home Press. That's why we divided the Boomerang book into 3 parts. The what, part 1, clarifies the time value of money terminology and lays the foundation for this new take on this age-old concept. The how, part 2 of the book, includes the first of its kind user manual for the mathematics of finance. And the why section, that tells you a little bit more about my story and just might help you to write yours. So if you haven't purchased your copy yet, all the important information on this all-important topic is gift wrapped within the cover of Would Your Boomerang Return? Until next time, enjoy the gift that is the present.